Hello everyone, I am Shobik Shaha. Today I will discuss about the conformations of 1,3-disubstituted cyclohexane. In the previous video, we were discuss about the conformations of 1,2-disubstituted cyclohexane. So you can find that video in the I button. So you can check out that video. So let's start our discussion from here. So we will first work with the 1,3-dimethyl cyclohexane. Later we will discuss about the another 1,3-disubstituted cyclohexane. So first we will discuss about the 1,3-dimethyl cyclohexane. We can discuss about this conformer of this conformer. So here you can see that there will be two conformers is present, and one is cis conformer and another is trans conformer. In the trans conformer, in the cis conformer, you can see that two methyl groups in the 1 and 3 positions are cis to one another, because you can see that the two methyl groups are in the same plane. Two methyl groups here are present in the same plane, and two hydrogens are present in the same plane. That is, if two methyl groups are above the plane, then two hydrogen atoms are below the plane. But in the trans conformation, you can see that there will be two hydrogens atom are placed opposite to each other. That is, one is placed above the plane and another is placed below the plane. And here you can see that one methyl group is present at the above the plane, and another methyl group is present at the below the plane. That is, they are trans to each other, and in the cis conformation, two methyl groups are cis to each other. Now we will draw the shear conformation of this cis conformations. So here you can see that this carbon, we will first draw the here we will draw the first shear conformation first, and then you can see that this carbon is, if we count the carbons here, this carbon is 1, this carbon is 2, this carbon is 3, and this carbon 4, this carbon is 5, and this carbon is 6. Here you can see that for the cis conformation, in the 1,3-disubstituted cyclohexane, the in case of the shear conformation, two methyl groups are present in the axial plane, and two hydrogen atoms are present in the equatorial plane for the cis isomer of the 1,3-dimethyl cyclohexane. And there will be ring flip will occur, and ring flip through the ring flip, these two methyl groups are will be placed at the equatorial position. That is, here you can see that two methyl groups are present at the equatorial position, and two hydrogen atoms are placed at the axial position, where in this case two hydrogen atoms are placed at the equatorial position, but through the ring flip, two hydrogen atoms are placed at the axial position. So here you can see that in this conformation, there will be much more steric strain is present, because you can see that in this conformation, where the methyl group is present at the axial position, so there will be absolutely 1,3 diaxial interaction is present. But in this case, where the two methyl groups are present at the equatorial position, here no steady here comparatively the less steric strain is present, because here you can see that two methyl groups are present at the equatorial position, so there is no so in this case there is no 1,3 diaxial interaction is present in this conformation. And now we will discuss about the shear conformation of the of the 1,3 disubstituted cyclohexane, and here the substitution is 2 methyl groups. So in the trans conformation, here you can see that one methyl group is present at the above the plane and another methyl group is present below the plane. So here you can see that one methyl in the shear conformation, here you can see that one methyl group is present at the above at the axial plane and another methyl group is present at the equatorial plane. So there, so if we ring flip this shear conformation, so if we ring flip this shear conformations, then there will be same configuration is present, because when we ring flip, because when the ring flip will occur, the this methyl group will go to the equatorial position and this methyl group will go to the axial position. So so in this so the two conformer will be present at the same composition. These two conformers are present at the same composition in the trans isomer. And here you now we will discuss about the optically inactive optically inactivity of the one of the cis 1,3 dimethyl substitute of 1,3 dimethyl cyclohexane. So first we will draw the cis 1,3 dimethyl cyclohexane. So here you can see that for cis 1,3 dimethyl cyclohexane, two methyl groups are present at the above at the same plane, and two hydrogen atoms are present at the same plane. So this is methyl, this is methyl group, these two are methyl groups, and these two are hydrogen atom. So this is a cis 1,3 disubstituted no one cis 1,3 dimethyl cyclohexane. Here you can here you can see that this is a cis 1,3 dimethyl cyclohexane, that is here two methyl groups are present at the same plane. So if we consider one plane that is present at this position, like I will show that. If we consider this type of plane that is present at this position, so here you can see that through this plane the two sides of the cis 1,3 dimethyl two sides of the 1,3 dimethyl cyclohexane will be symmetrical. So So here you can see that they are in the cis 1,3 dimethyl cyclohexane. There will be plane of symmetry is present in the molecule. So cis 1,3 disubstituted cyclohexane is a meso compound, and this is the meso compound. That is meso. You can see you can know that meso compound means that they are optically inactive compound. Next we will discuss about the conformations of 1,4 disubstituted cyclohexanes. Similarly, here we will work with the 1,4 dimethyl cyclohexane. Here you can see that this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5, this is carbon 6. So here you can see that two methyl groups are present at the one position, and another one methyl groups are present at the C1 position, and another methyl group which is present at the C4 position. Here also there will be two isomers is present, that is one is cis isomer and another is trans isomer. That is, in the cis isomer two methyl groups are present in the same plane, and in case of the trans isomer two methyl groups are present at the different plane. That is, one methyl group is present at the above the plane and another methyl group is present at the below the plane. And in this case the chair conformations of this cis and trans isomer is similar to the conformations of the 1,2 disubstituted cyclohexane. In the 1,2 disubstituted cyclohexane, there will be, if the cis isomer is present, then in the cis isomer of the 1,2 disubstituted cyclohexane, one substituent is present at the axial plane and another substituent is present at the equatorial plane. But and in the trans isomer there will be two substituents will be present at the axial position, or two substituents will be present at the equatorial position. In the cis isomer of the 1,4 disubstituted cyclohexane or 1,4 dimethyl cyclohexane, here you can see that in the chair conformation one methyl group is present at the equatorial plane and another methyl group is present at the axial plane. If the ring flip will occur, same conformation we will get, that is this methyl group this is present at the equatorial position and this methyl group is present at the axial position. So this methyl group is through the ring flip, this equatorial methyl group is go to the axial methyl group, is go to the axial position, and this methyl group and this axial methyl group will go to the equatorial position. So in this conformer, here you can see that due to this axial methyl group, there will be 1,3 diaxial interaction will be present. Through these two hydrogens. And in this conformer there will be one methyl group is present at the axial position. So there will be 1,3 diaxial interaction is present, but due to this methyl group there will be no diaxial interaction is present, and the same due to this methyl group is there is no diaxial interaction is present. So the two conformer of the cis isomer is present at the same composition. And here you can see that the if we consider this type of plane in this cis isomer, so there will be symmetries present in the compound. So the cis isomer of the 1,4 dimethyl cyclohexane, this will be meso compound or optically inactive compound. Now we will consider about the trans isomer of the 1,4 dimethyl cyclohexane. For the 1,4 dimethyl cyclohexane, two methyl groups are present at the whether two methyl groups are present at the axial position, or two methyl groups are present at the equatorial position. So in this diaxial conformer there will be mode 1,3 diaxial interaction is present. So in this case the diaxial interaction, um, in this case the diaxial conformer is more stable than the di-equatorial conformer of the 1,4 disubstituted cyclohexane, because in the 1,3 because in the diaxial conformation there will be more steric strain is present, but in the di-equatorial conformer there will be less steric strain is present. So in the equilibrium the more di-equatorial conformer is present than the diaxial conformer, because in the trans isomer of the 1,4 dimethyl cyclohexane. So next we will consider an example of 1,4 disubstituted cyclohexane. Here we will consider the two substitutions are different. Here you can see that the one is methyl group and another substituent is this is 2 degree or 2 degree carbon, or the secondary carbon. And so in case the cis conformation, if the methyl group is present at the if the methyl group is present at the axial position and and the modes and the 2 degree carbon, that is the or 2 degree carbon or 1 degree carbon or tertiary carbon which is present at the equatorial position, that conformer is more stable than the action then methyl group is present at the equatorial position, and the larger conformer no larger substituents which is present at the equatorial position, that is like primary carbon, 2 degree carbon, 3 degree carbon, etc. So in case of the cis conformer, this is the stable, this is the most stable conformer than this, because in this case where the 2 degree carbon is present at the axial position are less stable due to the presence of the 1,3 diaxial interaction between this group and these hydrogens and these hydrogen. But in this case you can see that this 1,3 diaxial interaction is less in this case, where the methyl group is present at the where the methyl group is present at the is present at the axial position, and the bulkier group, that is the 2 degree or 1 degree or 3 degree or 3 degree carbons, which is present at the equatorial position. So this conformation is more stable, but in the trans isomer, you can see that one methyl group is present at the one methyl group is present at the axial position, and another 2 degree of carbon is present at the axial position. So this is the least stable, because there will be more 1 3, because in this conformer more 1 3 1 3 diaxial interaction is present than this, because in this case this 2 degree carbon, you can see that, and these methyl groups are present at the equatorial position. So there will be no 1 3 diaxial interaction is present. So in this case, this conformer is more stable due to the less steric strain of this conformer. Mm, so so this conformer is more stable in the trans isomer. This conformer is more stable in the trans conformer, where the two substituents are present at the equatorial position, and in the cis conformer, if the two substituents are present at the are the same, if the two substituents are same, because like there will be two methyl group, then there will be same, and then there will be no, then there will be no conformation will be predominates in the equilibrium. But when there will be distinct groups are present, that is like methyl group, and say 1 degree carbon, 2 degree carbon, or 3 degree carbon. So if when where the in the conformation, where the small groups are present at the axial position, and the and bulkier groups which is present at the equatorial position, that conformer is more stable than the bulkier than the conformer and then the conformer, where the bulkier group is present at the axial position, and the methyl group, that is like smaller groups, are present at the equatorial position. So this is for this video. If you like this video, then you can smash the like button,